In this lesson, we will discuss formulas and applications. So to begin with, we want to first understand what is a formula. So a formula, by definition, is an equation that expresses a known relationship between two or more variables. So one main context in which we'll see formulas is geometry. So when you took geometry, I'm sure learned a lot of different formulas for area, perimeter, surface area, volume. So most of these we're going to show should be reviewed for you. There's a couple that maybe looks a little different or might be completely new to you, but hopefully a lot of these are familiar. So first off, we have perimeter and area of a rectangle. So perimeter is found by doing 2 times the length plus 2 times the width. And then area we can find by doing length times width. And then for a square, the perimeter we find by doing 4 times the side length. And area would be the side length squared. So we have side times side. For a triangle, the perimeter is found by just adding up the side lengths, a plus b plus c. And the area is found by doing 1/2 times the base times the height of the triangle. For a circle, we have circumference and area. Circumference is the distance around the circle. We find that by doing pi times diameter, or 2 times pi times radius. Then area is found by doing pi times radius squared. A parallelogram is similar to a rectangle. The perimeter we would do 2 times the one side length, and then plus 2 times the other side length. And the area is found by doing base times height. So the height would be, should be over here, this perpendicular distance. So that would be your 2-dimensional objects. And then we have 3-dimensional shapes. So we have prisms and we have cones. So here we have a rectangular prism or rectangular solid. And the surface area formula might be a little different than the way you learned it, but it still gives you the same result. And here we have 2 times length times width plus w times plus width times height plus the length times height. And volume we find by doing the area of the base times the height. So area of the base would be length times width, and the height would be h. Then for a cone, here we have a right circular cone. The surface area formula given here is probably different than the way you learned it, but it gives you the same end result. All right, so here we have r for radius, h for height, and then you can just plug in numbers to find the surface area. And then volume is 1/3 times the area of the base times the height of the cone, and the area of the base is pi r squared. So we have 1/3 times pi r squared times h. And then a sphere, the surface area is found by doing 4 times pi times the radius squared, and the volume is 4/3 times pi times radius cubed. And then we have a cylinder. Surface area, we need the area of the 2 bases and then the area of the outside. So the area of the 2 bases, we have pi r squared and then times 2 for 2 bases. And then the outside area, we need the perimeter of the base times the height. So perimeter of the base would be circumference, which is 2 pi r, times the height, which is the h. And then volume is found by doing the area of the base, which is pi r squared, multiplied by the height of the cylinder. And this last one you probably have not learned before. It's called the frustum of a cone. And so here we have different formulas, and I'll be honest, you really don't need this too much at the moment, but it's here if you want to refer to it. And this is to find surface area and volume of a shape like this. All right, where capital R would be the radius of the bottom, and then the lowercase r is the radius of the top of the shape. And then h would be the height. All right, so you have a formula here for surface area and then one for volume. Now with formulas, whether it be geometry or maybe physics or some other context in which you're using it, there's many times you need to solve for a different unknown. So like all of these are solved for perimeter and area, or surface area and volume. All right, there may be times though where you want to maybe solve for something different. So for example, Here we are given the volume formula, and this is for the volume of a cone. And with this formula, our objective is to solve for r. So to do this, we want to use our knowledge of solving for equations and use that here in this context to solve for the letter r. So what we need to do when we rearrange any formula is we need to work in reverse order of operations. So here, this one's not too bad because everything's being multiplied together. Right, we have 1/3 times pi times radius squared times height. So most of our work is going to be getting rid of the multiplication, which is done by dividing. So we can divide the 1/3, divide the pi, and divide the h. So when you divide by 1/3, that is the same effect as multiplying by 3. So we can multiply both sides by 3. So that cancels this 1/3 on the right side. We can also, like we said, divide by pi. So we divide by pi on both sides. That cancels on the right side. Then divide by h on both sides. So what we have is going to be 3v over pi times h equals radius squared. So we moved everything away from r, and now we just have to get rid of the exponent. So to get rid of the exponent, we do the inverse of squaring, which is square rooting. So we take the square root of both sides. When you do that on the right side, the square cancels out. You're left with an r. And the left side, you have all of that inside of the square root. And now from here, just take note that with a radical, the standard way of writing radicals is by eliminating the denominator from being inside of the radical. So what we need to do is get rid of the pi h from being inside of the radical. And to do that, we can separate into two different parts and then multiply the top and the bottom by this radical down here. So if you multiply top and bottom by the square root of pi times h, what happens is on the top we have the square root of 3 times v times the pi times the h, all inside of the same radical. And then divide by, and then the square root of pi h times the square root of pi h. That would give you just pi times h. So r would equal this right here. Alright, so that is our first example. We'll do another example over here where we have surface area equals 2 pi r h plus 2 pi r squared, and we are solving for h. Alright, so this one has a little more work to do. So h is right here. And with the h, we have multiplication of the 2 pi r right there. And we also have the addition of 2 pi r squared. When you're solving, remember we need to work in reverse order of operations. So if you think through your order of operations, addition is normally last. But when working in reverse, that's going to be the first thing we want to move around. So we can remove this to the left side by subtracting 2 pi r squared from both sides. So now this cancels on the right. We're left with SA, surface area, minus 2 pi r squared on the left equals 2 pi r h on the right. Now to solve for h, from here, we just need to get rid of the 2 times pi times r. We take care of that by dividing by 2 pi r. So we divide both sides by 2 pi r. Right side we have h, left side we have the surface area minus 2 pi r squared, and all that is over 2 times pi times r. So if we want, we could leave it like this because h is already solved for. But we could also separate this left side if we wanted to into two different fractions where we have SA over 2 pi r minus, so then minus 2 pi r squared over 2 pi r. Well, if you have 2 pi r squared over 2 pi r, the 2's cancel, the pi's cancel, r squared over r would just give you r. So what we have here would be minus r. That's where that comes from. So you could write it like that if you want, separate into two different fractions. And we did that here because we noticed that this part of the fraction would all pretty much cancel out. Alright, so we've dealt with formulas. So we've shown you some examples of geometry formulas. We've worked with rearranging different formulas. Now we're going to use different formulas to solve actual problems. So if you're solving an actual application problem, there's kind of a strategy you can follow to help you with any type of problem. And so the strategy is, first, obviously you want to read the problem carefully and make sure you figure out what it's asking for. So from here, if necessary or if applicable, you can draw a sketch and label the parts. This is especially helpful for geometry type questions. You can draw yourself a picture of what is happening, but there's some times where that's not really possible. So if possible, do that, and then from there we can determine unknown quantities. Whatever we're trying to find, whatever is unknown, we can write them using variables. And then once we have the variables, we can then write an equation that relates those different unknown quantities. All right, so from there, we can use this information and a known formula, and then we can produce our equation with which we can then solve. Once we solve the equation, you can double check just to make sure you got it correct. So this here is 5 steps that can help you as you try to figure out different application problems. So from here on in the lesson, we're going to show you different types of problems that you might come across. And again, with application problems, there's an infinite number of ways you can apply these different formulas and these different thought processes. But our objective here is to show you just a couple of different types of problems that you might come across and how you can approach those specific types of problems. So our first application problem, this one, we are told that Jan is starting a garden. She has 150 feet of fencing to go around the garden to keep the animals out. She wants to have a length to width ratio of 2 to 1. What will the dimensions be of her garden? So this one is more of a geometry type question. So first step is read the problem carefully. All right. From here, we want to draw a picture, if applicable, and then maybe label the picture. So it says we have a rectangular garden. And I guess we are assuming it's a rectangle because most gardens are rectangles. And so here we have a rectangular garden where we have the length and we have the width. All right, so from here, okay, we can establish different things we know about this picture and about the problem. We know we have 150 feet of fencing, and we know the length to width ratio is 2 to 1. So using that length to width ratio, all right, we can figure out how to set up our variables. All right, so if it's a length to width ratio of 2 to 1, that means length divided by width would be 2 over 1, right? So we can see that here. Length divided by width equals 2 over 1. Or in other words, if we cross multiply, we have length times 1 equals 2 times width. We have 1 length equals 2 width. So length equals 2w. So this length here, we can replace that with an equal sign, 2w. So we've established our variables, and we also know the perimeter is 150 feet. So perimeter, okay, this is going to require you to know the formula for perimeter of a rectangle. And as we discussed previously, the perimeter formula is 2 times length plus 2 times width. So from here, once we have the variables established, we have the formula we need, we can plug in information to create our equation. So in place of P for perimeter, we plug in 150. In place of the length, we said length is 2w. So we plug in a 2w in place of length. And then w is just w. So from here we have an equation with which we can solve. So 2 times 2w is 4w. 4w plus 2w is 6w. Divide both sides by 6, and w would equal 25. So the width here is 25, and the length is 2 times that. 2 times 25 would be 50. So we have a width of 25 feet and a length of 50 feet. So that is one type of problem you might come across. So dealing with geometry and ratios, make sure you know your formulas as well, because without the formulas you won't be able to get the proper equation. So another application is with similar shapes. So in math and geometry, many times you come across similar shapes, and we can use similar shapes to create a proportion with which we can solve for an unknown value. All right, so here in this picture we have two triangles, and if we're assuming these triangles are similar, our objective is to find the value of x. All right, so there's different ways you can set up your equation here. But what we can do, one way, is realize that with similar shapes that the ratio or the scale factor is going to be the same. Doesn't matter what pair of sides we look at. So for example, if we look here at the bottom of this triangle and the bottom of this triangle, that's going to be in the ratio of 8 to 5. That ratio or scale factor is going to hold true for any corresponding sides. So if we do x divided by 3 right here, that's going to be the same ratio, the same scale factor. So we can use this to set up our equation. So we can have 8 over 5 equals x over 3, and then we can cross multiply and solve. We have 5 times x equals 3 times 8, so we have 5x equals 24. Divide both sides by 5, so x would equal 24 over 5, or 4.8. So the length of x right up here would be 4.8. And again, there's different ways you can set up the proportion. What we could have done is we could have compared the side lengths within the same triangle. So we could have done x over 8, so the left side divided by the bottom, equals 3 over 5 on this triangle, which is the left side divided by the bottom of this smaller triangle. If we solve this, it's going to give you the same solution. We have 5x equals 24, and x would equal 4.8. So the proportion or the equation that we create could be set up in different ways, but either way we should get the same solution if we do it correctly. So we've done some geometry application. Next we're going to talk about profit. So profit, this is dealing with a business application. So profit is going to be found by taking the revenue or income or money coming in and subtracting out the cost. So like quick example, let's say you are selling cookies and it costs maybe $6 to make and you sell it for $10. Your profit would be the income, the money coming in, subtract by the cost. So your money in this example would be 10 minus 6, which would be $4. So your profit in that example would be $4. So that's the idea behind this formula. And here we have a little more difficult problem, but we are told that a company makes candles. Each candle costs $4.87 to make, and they sell each candle for $10. How many candles will this company have to sell in order to make $1,500 profit? Now to solve this, and with any application problem, there are different ways you can approach this. So there's not just one right way in which you can solve. So here we're just going to show you one way in which you could find the correct answer. But here at the beginning, obviously you want to read the problem, and here there's no picture to draw, there's no shapes, no diagrams needed. And then we need to establish our variables. What are we trying to find? So here the question is asking, how many candles will this company have to sell? So our unknown is number of candles, and we'll call that x. So from here we can set up an equation. So profit we want to be $1,500. Okay, the revenue would be found by doing $10 times the number of candles. That's how much money is going to be coming in. So we have 10 times x, or 10x. And we see that typed up right here. And then the cost is $4.87 per candle. So the cost is $4.87 times the number of candles, so times x. So here we see an equation. We have 1500 equals 10x minus 4.87x. And then if we combine like terms, 10x minus 4.87x, that gives you 5.13x. And then divide both sides by 5.13, and that gives you 292.4. So what this means is that the company needs to sell 292.4 candles, which you can't sell a part of a candle, so you round it up to 293. So we can conclude that the company will need to sell 293 candles to make $1,500 profit. So let's take a look at another type of money problem. Here we have an interest problem. So here we're told that interest is equal to the principal times the rate times the time. So principal is the amount that you're investing or that you are maybe taken out as a loan. The rate would be the percentage. The time is going to be in years. So in this example, okay, John invests $10,000 into two separate accounts. One earns 4% simple interest, the other 7.5%. How did he invest into each account if his total interest made was $540? So it should be how much did he invest? So how much did he invest into each account? All right, so step one, as always, is read the problem. Step two is draw a picture if needed, and here there's no picture. Step three is establish your variables. All right, so what are your variables in this situation? Well, the question is, how much did he invest into each account? So how much? It's an amount. So we have two accounts. We can let the 4% account be represented by the letter X. And if that's the case, the interest earned from that we find by doing principal times rate times time. The principal is X. That's the amount that he invested. The rate is 0.04, and the time is going to be 1. It's 1 year. So we have 0.04 times X as the interest earned. Now the other unknown is the principal, or the amount invested, into the 7.5% account. Well, we know the total amount invested is $10,000. If he invested X into 4% account, if we do 10,000 minus X, that is how much he invests into the 7.5% account. So if that's the principal invested into this account, we can then find the interest earned by this account. So the principal is 10,000 minus X, and then we multiply that by the rate, which is 0.075, and then the time is 1 year. So we don't need to write the 1 because it doesn't affect anything when you multiply. And so we have that as going to be our interest. All right, and we see that typed up down here, 0.075 times 10,000 minus X. So we've established our variables, and we've kind of put things together. And now from here, we can create an equation with which we can solve. All right, so it says that the total interest made was $540. So that means if we take the interest from this account, 0.04x, plus the interest from this account, so this amount right here, and add those together, that would equal 540. So step 4 is creating our equation. So we have 540 equals the sum of those two amounts. Now from here we can solve. So we can distribute the 0.075 to both terms, and that would give you 750 minus 0.075x. Then we can combine like terms, 0.04x minus 0.075x, and that would give you negative 0.035x. And then from here, we can subtract 750 from both sides. So we have 540 minus 750. That would give you negative 210. Then divide both sides by negative 0.035. That would give you x equaling 6,000. So x, the amount in the 4% account, is going to be 6,000. That is our first unknown. Second unknown is we want how much was invested in the other account. Well, we know total it was 10,000. So we do 10,000 minus x, so 10,000 minus 6,000. That gives you 4,000 in the second account. So the answer is $6,000 in the first account and then $4,000 was invested in the second account. Now switching gears a little bit, we're going to talk about distance. So next we have distance, and the formula is distance equals rate times time. So in this particular example, we are told that if Elizabeth begins running at a constant rate of 5 miles per hour, and then 10 minutes later, Kevin begins running at a constant rate of 7 miles per hour, how long after Elizabeth starts will it take for Kevin to catch up to her? Alright, so step one, as always, is read the problem carefully and then draw a picture if needed. And here there's not really a picture to draw. And then from here we can establish our variables. So what is the question asking for? So the question is asking how long after Elizabeth starts will it take for Kevin to catch up to her? So length of time would be our unknown. So time will be our x value. And then we can kind of put things together. So for Elizabeth time, that is the x value, she's running at a rate of 5 miles per hour. So her rate is 5, her time is x, so her distance would be 5 times x, or 5x. Okay, now Kevin's distance we can figure out. So Kevin, he's running at a rate of 7 miles per hour. Now the time that he ran, it says he began 10 minutes later. So he started running 10 minutes after Elizabeth started running. So if he started later than Elizabeth, that means he ran 10 minutes less than her time. So if her time was x, Kevin's time is going to be x minus 10 minutes. But minutes needs to be put into hours because here we have miles per hour. So 10 minutes would be 10 over 60 of an hour, which is 1/6 of an hour. So the time was x minus 10 minutes, which is minus 1/6 of an hour. So Kevin's distance would be 7 times, and then x minus 1/6. So we used our variables to kind of put some things together, and then from here we can create an equation. So our equation is realizing the fact that the total distance traveled by both Elizabeth and Kevin are equal, right? Because here is where Elizabeth is starting. She's running in this direction. Kevin is starting in the exact same spot, running in the same direction, and eventually he's going to catch up with her at some point. So the total distance will be equal. So we can take this 5x and set it equal to 7 times x minus 1/6. So now that we have that, that will be our equation with which we can solve. So we can begin by distributing the 7 to both terms. We get 7x minus 7/6. And then we can solve by subtracting 7x from both sides to bring it over here to the left. So we have 5x minus 7x, which gives you negative 2x. And then we can get rid of the negative 2 with the x by dividing both sides by negative 2. When you divide by negative 2, that's the same thing as multiplying by 1/2. So we have here 2 negatives make a positive. We have 7 over 6 times 2, which is 12. So the answer is x equals 7/12 of an hour. That is how long it's going to take for Kevin to catch up with Elizabeth. And then we can convert that into minutes. So if we do 7/12 times 60, because 60 minutes in 1 hour, we can get that to cancel. We have 7 times 5, which gives 35. So 7/12 of an hour, or 35 minutes, is how long it takes for Kevin to catch up with Elizabeth. Now, switching gears again, we are going to talk now about percent mixture problems. So in this example, okay, we're dealing with different types of nuts. We're trying to make some sort of mixture of peanuts. So here we have 9 pounds of mixed nuts containing 55% peanuts, and they were mixed with 6 pounds of another kind of mixed nuts that contain 40% peanuts. And the question is, what percent of the new mixture is peanuts? So this example is dealing with peanuts, but it could be, any different type of mixture. it could be dealing with a saline solution. It could be dealing with some sort of chemical. All right, so the application can be extended beyond just peanuts here, but the thought process is going to be the same or very similar. So step one, as always, is read the problem and then draw a picture if necessary, which here there's no picture to draw, and then establish what is your variable. So the variable here, what we're trying to find, is what percent of the new mixture is peanuts. So your variable x will be the percent of peanuts in the final mixture. And now that we have the variable established, we can kind of draw some other conclusions from the information given. And then after that, we can create an equation with which we can solve. All right, so with the final mixture, okay, it's going to be some percentage of peanuts. Now, the final mixture is going to be a total of 15 pounds, right? We have 9 pounds of one type of nut or one type of mix added with 6 pounds of this other kind of mix. So together, the weight is going to be 15 pounds total. Now, of that 15 pounds, X percentage of that will be actual peanuts. All right, so if we do the 15 times X times that percentage, that will give you the amount of peanuts in the final mixture of nuts. So your thought process is going to be kind of putting this all together, where you want the amount of peanuts in each type of mix added together to give you the amount of peanuts in the final mixture. So if you look at the 9-pound mix here, that has 55% peanuts. If we do 9 times 55%, so 0.55 times 9, that gives you the amount of peanuts within that mixture. So we see that typed up right here. 0.55 times 9 is the amount of peanuts within that mixture. Now the other type of mix is 40% peanuts, and that mixture has 6 pounds. So if we do 6 pounds times 40%, so 6 times 0.4, that gives you the amount of peanuts within that mixture. So if we put these two together, the amount within these two mixtures separately, and you add those together, that gives you the amount of peanuts in the final mix. So we can use that to create an equation. We have 0.55 times 9 plus 0.4 times 6. That equals the total amount in the final mixture, which is 15 times x. So we can multiply 0.55 times 9, that gives you 4.95. 0.4 times 6 gives you 2.4. You add those together, that gives you 7.35, and that's equal to 15x. And then we can divide both sides by 15. So then x would equal 7.35 divided by 15, which would equal 0.49. So that is your value for x. That is the percentage of peanuts in the final mixture. So 0.49, which would be 49%. So again, this thought process can be used for any sort of mixture problem, whether it be with like physical items like this, or it could be some sort of chemical or some sort of liquid. So your thought process is going to be very similar. And again, you might be finding different types of things within the problem. So here we're trying to find a percent. Other times you might be finding the amount of weight needed. So you just have to read the problem carefully to determine what is being asked. So now we have this type of problem, and then the last kind is going to be a work problem. So this one, our example, we have Rob can tar a roof in 9 hours. Kayla can tar a roof in 12 hours. How long would it take them to finish the job if working together? So again, step one with any word problem is you want to read the problem carefully, draw a picture if needed, which here there is no picture to draw, and then we can kind of establish our variables and then put together information to then create an equation with which we can solve. All right, so our variable, what we're trying to find, says how long would it take them to finish the job if working together. So our unknown is going to be an amount of time. And you can write that out if you want. X is some sort of amount of time. And from here, we can kind of use that to set and put things together. All right, so this type of problem, we need to understand what's called the work rate. And that's the idea of how much work can a person complete within 1 hour. That is the work rate. So Rob, for example, it takes him 9 hours to complete the job. So his work rate would be 1/9, because within 1 hour, he would complete 1/9 of the job. Kayla takes 12 hours. That's a typo, should be hours, not house. She can tar a roof in 12 hours. So her work rate, meaning how much work she can complete in 1 hour, is going to be 1/12. All right, she'll complete 1/12 of the job within 1 hour. And we see that typed up right here. So notice the relationship, though. We can convert back and forth between the time to complete the job and the work rate. It's going to come into play a little later at the end of the problem as well. So these are like reciprocals, right? We have 9, 1/9, 12, 1/12. So that's the relationship. Now the question is asking, working together, how long would it take? So if you take their rates, so the 1/9 and 1/12, add them together, that will be how much of the work they can complete within 1 hour. Right, so together they would complete 1/9 plus 1/12, which, assuming you know how to add fractions, that would give you 7/36. So that means within 1 hour, they'll complete 7/36 of the job. Now remember, we mentioned just a moment ago that we can take the work rate. So if we take the work rate, we can go back the other direction and we can get the time needed to complete the job. Right, like the 1/9 was the work rate, and then if we flip the top and the bottom, that gives you 9, which is the length it takes to complete the job. So same thing here, we can take this work rate together, and then we can find the reciprocal, flip the top and the bottom to get 36/7, and that is the amount of time it takes for them together to complete the job. And that's it. So we have 36/7 of an hour, so we can divide, we get 5.14 hour. And the decimal we can write as in minutes, right? Because 0.14 hours multiplied by 60, that would give you what? 0.242. That would give you 8.4 minutes. So this job, working together, would take them 5 hours and 8.4 minutes. And then for any word problem that you do, always double check to make sure your answer makes sense. All right, so here, if they're working together, it's going to take less than 9 hours, right? Because Rob takes 9 hours by himself. So together it's got to be less than 9 for sure. So this answer makes sense, so we can probably assume that we have done it correctly. If you get some crazy answer, something greater than 9 or greater than 12 or whatever, in this example, it's obviously not done correctly, and you want to go back and double check. So these are just a few different types of problems that you might come across, and you can use these different thought processes to maybe help you with other types of application problems as well. And that concludes our lesson for today. We will see you next time.